Hi, everyone. Welcome to our discussion on the second big piece of data of macroeconomics. As I told you before, as we start the macro section, we have three big pieces of data that we have to understand before we can really talk about understanding how the economy works. We just have to understand the data and how the economy is measured before we can really go further. So last time we talked about GDP, how we measure income and output, and now we're going to talk about the Consumer Price Index, which helps us understand the cost of living and how that's changing. Another way of saying that is the Consumer Price Index helps us understand inflation in the economy, gives us a sense of how overall prices are rising over time, whether that's happening rapidly or slowly, etc. So let's go to screen share. I am also using a PowerPoint again for this piece of data, and I'm not going to use my little, funny looking scribbles. Anyway, the CPI. As I said before, we're measuring the increase in the cost of living. So the way that we think of this is think of the typical household and think of kind of the standard of living that that typical household enjoys. So that has a cost associated with it. So how is that cost rising? How is the cost to maintain that typical standard of living for the typical household? How is that rising? The Consumer Pricing Index, it's based on, the goods and services that are generally bought by the typical household in the economy. So we have several steps in computing the CPI. They're all very straightforward. I mean, this is plain vanilla stuff. I mean, this chapter is not rocket science. We do get to some important points at the end, but first and foremost, this is just nuts and bolts stuff. Just listen to this video real quick and you'll have it and it'll be straightforward enough. Anyway, the first step is just to determine the basket of goods and services that represents the purchases of the typical household. So the government does surveys for this. The government does thousands and thousands of surveys regularly. This comes from the Bureau of Labor Statistics within the Department of Commerce. They do thousands of surveys to just gauge what kind of stuff does the typical household buy. So this is based on purchase of a typical household. Like specialty items may not be captured in this at all. Like a Lamborghini. I don't know. I don't even really know what a Lamborghini is. I've never seen one. I know it's a term that people use when they're talking about a really fancy exotic car. Anyway, a Lamborghini, that's not in the CPI, right? Because it's bought by a very, very, very small percentage of high income, high wealth people. It's not part of the CPI. CPI gauges typical stuff. And this figure here shows you just kind of the basket of goods and services that the Bureau of Labor Statistics uses. The goods kind of fall into these categories. Housing's 43%, transportation 17%, blah, blah, blah. And this basket, of course, correspondingly, it reflects kind of the expenditure patterns of the typical household, right? Typical household spends 4% of its income on clothes, apparel, the purple section there. So, so 4% of the stuff in the CPI's basket is clothing related. Anyway, we're going to go through a kindergarten example here where we only assume there are two goods in the economy. In reality, that basket has thousands of goods. We're going to assume there's just two goods, pizzas and lattes. This is the same kind of example we did last time in the previous chapter, but even though it's vastly oversimplistic, it'll still give you an understanding of how this works. So we're going to assume that the basket of goods and services that the BLS uses based on these surveys is 4 pizzas and 10 lattes. That's weird, but that's the example we have. So we form the basket, and then we just track the prices of those goods every month. The CPI is a monthly statistic. So here in this figure, you can see how the pizzas go from 10 to 11 to 12, and the lattes go from 2 to 250 to 3. And then we compute the cost of the basket, right? So the basket has 4 pizzas and 10 lattes. So right here, we're looking at the price of pizza times 4 pizzas, okay? And then sum that with price of lattes, 2 times 10 lattes. The cost of the basket was $60 in the first year. And the basket's not changing here. The basket is staying at 4 pizzas and 10 lattes. So the basket's not changing. The quantities in this little calculation are not changing. But you see how we're doing the same calculation for the second year. We just update the prices, doing the same calculation for the third year, and just updating the prices. So we see the cost of the basket goes from 60 to 69 to 78. Now then, to actually construct the index, this is kind of like what we did with real GDP. we have to select a base year. We have to select some year as our basis of comparison. And the base year is arbitrary. It doesn't matter really which year you select. It's just an arbitrary starting point to form the calculation. Anyway, in this example, we're going to just use the first year as the base year, and that's straightforward enough. So the CPI itself is the cost of the basket in a given year relative to the cost in the base year. So 60 divided by 60, the cost in a given year relative to the cost in the base year, and then it's scaled by a factor of 100. So the CPI is 100 for the base year. The CPI is necessarily, by construct, 100 in the base year. Then for the second year, the cost becomes 69 relative to that initial value, again, scaled up by a factor of 100. The CPI becomes 115 for the second year, and then 130 for the third year. So that's the CPI, that's the index itself. But then the number that we actually look at is the rate of change in the index, just the rate of growth in the index from one year to the next, or 1 month to the next, or whatever. So we're just calculating the change for the change from the first year to the second year relative to the initial year's value, multiplied by 100 to get into percentage terms. We're figuring out that inflation is 15% for the second year over the previous year. Same idea here, the rate of change from the second to the third year relative to the second year's value. We're finding that inflation is 13% for the third year over the previous year. That's all there is to it. It's just plain nuts and bolts. It's very straightforward. It's not that complicated at all. But that's how the CPI is constructed. That's how we calculate the rate of inflation in the economy, one of our key metrics. This figure just shows you how inflation has changed over time. Have this big spike of inflation in the early 50s after World War II. In the 60s, we're looking at inflation here when it was stable at this point. We're looking at inflation that's around 3%, 2 or 3% was pretty normal at the time. Then we have this huge spike in inflation starting in the late 60s, going through right at the very beginning of the 80s. This period here is called the Great Inflation. We're going to come back later and talk a little bit about economic history, and I'm going to tell you about how the Great Inflation happened. Right? This isn't the Great Depression. Right? The Great Depression was characterized by huge drops in GDP and huge increases in unemployment back in the 1930s. But this is the Great Inflation of the 70s. And it's really an important part of economic history. We learned a lot from that episode. Then inflation gets back down. Inflation gets pretty stable here at around that 2 or 3% range. Inflation was a little bit fuzzy here during the previous recession in 2008, 2009. But ever since then, inflation has been really stable at around 2%. Except for the recession in 08 or 09, for this entire century, for the last 20 years, inflation has been pretty stable at around 2 or 3%. And we'll talk later in the course about, how we've managed to get inflation to be so stable and so kind of, it just moves in a very expected way. It doesn't move in a surprising way. And that's actually a real big achievement of economic history. And we'll talk about, how we've been able to engineer that and talk about how we can maintain that, hopefully. I just will say inflation tends to be, we use this term called pro-cyclical. Inflation tends to be pro-cyclical. Last time we talked about the business cycle, and the business cycle is defined by GDP, right? We have these periods of economic growth when GDP is rising. We have these periods of recession when GDP is falling. That's where we are right now, unfortunately. But that's the definition of the business cycle. But inflation tends to move with the business cycle. So when the economy is rising, inflation tends to be rising as well. And when we're at the peak of the business cycle, inflation tends to be high. When the economy is falling, inflation tends to be falling as well. We're at the trough of the business cycle, inflation tends to be low. That's not always the truth. That's not always the case. There are definitely exceptions to that. The Great Inflation actually was a big exception to that. But we'll talk more about how that happens and how that works out. But just know, as a general rule of thumb, inflation tends to be pro-cyclical, meaning it moves with the business cycle. There are problems with the CPI, right? We talked about problems with GDP. Just in the same sense, there are problems with the CPI as well. This isn't surprising. I mean, the economy is very big and very complex, and we're trying to capture kind of grand ideas with these statistics, right? With GDP, we're trying to capture kind of some measure of the overall quality of life in the economy. Here, we're trying to measure how fast the cost to maintain this typical standard of living is increasing. Big ideas that we're trying to capture. So it's not surprising at all that we have imperfections in the data in achieving those goals. For the most part, I'm going to let you read about these problems in the textbook. These problems are not that complicated, so I'm not going to spend a whole lot of time on them. But the one that I am going to talk about, the one that you should know, is substitution bias. Substitution bias is undoubtedly the biggest problem with the CPI, and it's a pretty big problem. The notion is this: we gauge this basket of goods and services that represents consumption by the typical household. And then we just leave that basket there. We don't change that basket. We do change the basket over the long term. The basket does evolve gradually over the long term. But in the short term, just from month to month, that basket is fixed. But in the real world, the basket of stuff that you buy isn't fixed. If you typically buy apples, if the price of apples goes up relative to the price of oranges, then you very well may switch over to oranges, may substitute away from the relatively more expensive good over to the relatively cheaper good. That's obvious, that's straightforward. That doesn't take a genius to imagine that. So people have the ability to substitute for cheaper goods. People do that all the time. People do that constantly. But the CPI doesn't allow for that. So the CPI overstates the increase in the true cost of living because it doesn't take into account this ability that consumers have to substitute over to cheaper goods as relative prices are changing as the economy is evolving over time. That causes the CPI, as you see here, that causes the CPI to overstate the increase in the true cost of living. So the typical inflation number that we're looking at nowadays, as I said a second ago, is about 2%, right? We expect about 2% inflation annually, right? If this basket of goods and services cost $100 on January 1st, then by December 31st of that year, we expect the basket to cost about $102. 2% inflation is what we expect. So because of this substitution bias problem and because of other problems that I'm not going to talk about that I'm just going to let you read in the book, we think the CPI may overstate the increase of the true cost of living by up to 1 percentage point. But that's off of a basis of 2. So if the CPI is telling us that inflation is increasing by 2% per year, it's very reasonable to believe that a 0.5% of that, or even 1% of that, may be due to this bias, may be due to this measurement error in the data. That's a big difference. That's a big problem. We have to be aware of that when we think about the CPI. And that can come back and create problems in other ways. That can create problems in other areas of the economy. Some of the homework problems in the end of the chapter in the book, some of the things that we'll talk about on the quiz, etc., will highlight how this bias, how this way in which the CPI overstates the increase in the true cost of living, we'll talk about how that creates distortions and how that creates problems in the economy. Here's a little technical thing that we can do with the CPI. This is kind of a nice little trick that you may very well need to come back to and rely on when you're kind of going through your life or your business. But here the topic is we're going to adjust dollar figures across time. We're going to compare dollar figures from different times. The example we're going to use here is Babe Ruth's nominal salary in 1931 was $80,000. So the number of dollars that Babe Ruth received in 1931 was 80,000. Babe Ruth was the top baseball player at the time, back in 1931, he was the highest paid baseball player at the time. That's why we're using Babe Ruth in this example, because he was kind of a famous, big, high income person back, 90 years ago. But for me to tell you that he earned $80,000, that really doesn't give you any information because prices were very different back then. Right now, if you're going to go out and buy lunch costs you $9 or $10. Back in 1931, lunch would probably cost you 10 cents or something like that. At the very least, you'd be paying in change. You wouldn't be paying in actual, you wouldn't be paying in dollar bills to be paying in change. Lunch would be so, cheap in that simple sense. So for me to tell you that he earned $81,000, honestly, it gives you no information because you don't really have a good sense. You don't have a good feel for what prices were like in 1931. It doesn't mean anything. I mean, you care about how much he could buy, right? You don't care about how many dollars he received. That's a nominal variable. That's a variable that doesn't have any substance to it, really. What you care about is how much stuff could Babe Ruth buy with that figure. So to actually get a meaningful number, we have to convert, the way that the lingo that we would use is we have to convert Babe Ruth's salary from 1931 into today's dollars. We have to convert his figure, his earnings figure, into today's dollars to get a number that is meaningful, to get a number that's meaningful to us, to get a number that really gives us a sense of how much stuff he could buy, not just simply how many dollars he made. So what we have to do is we're going to take Babe Ruth's salary in 1930, which was the $80,000 figure that we said, and we're just simply going to multiply it by the ratio of the price level today relative to the price level 90 years ago. Okay? See, this ratio will tell you, how much inflation has been, right? If the price level today is 200, if the price level back then was 100, if that happened to be the base year, this ratio is 200 divided by 100. That just tells you the prices have doubled. Whatever that ratio is, that gives you a sense of overall how much prices have increased. Just multiply that ratio by the old dollar figure, and that gives you the dollar figure in today's dollars. So this example is old here. I'm kind of embarrassed that this is 10 years old. I haven't updated these numbers in 10 years, but it doesn't matter. The point doesn't change. The point is completely the same regardless of whether I would update this for today. Anyway, you would just look this up, right? You'd go to the Bureau of Labor Statistics website, or, the statistics are reported on numerous websites nowadays. But you'd go to the Bureau of Labor Statistics and just look at what the CPI was. You'd find that in 1930, the CPI was 15.2. And then today, again, this example a little bit out of date, but you'd find that the recent CPI is 214. So just take the $80,000 figure, multiply it by that ratio. I mean, you can see prices have really gone up, right? The overall level of price in the economy has gone up from 15 to 215. That's been a lot of inflation over the course of the last 90 years, of course. But do that calculation, you find that Babe Ruth's 1930 salary expressed in today's dollars comes to about 1.1 million. Does that make sense? Babe Ruth's 1930 salary expressed in today's dollars comes to about 1.1 million. So if Babe Ruth were here today, with the money that he received in 1931, he could buy about 1.1 million worth of stuff. And you know what prices are today. You've got a pretty good sense of how much stuff costs. You have a pretty good sense of how much 1.1 million can buy. Right? 1.1 million can buy way more than what I'm buying on a typical day or typical year. So the 1.1 million is a number that's meaningful to you, that actually tells you how much stuff he can buy in numbers that you can understand since you're accustomed to today's price level. I hope that makes sense. But you can't just look at a dollar figure from the past and expect to have information, expect to have meaning from it, because the price level has changed so much. You have to make that conversion. You have to adjust the figure for inflation. That's an important way to determine as well. You could say you could convert you can convert the old dollar figure to today's dollars, or you could also say you can adjust the figure for inflation. Anyway, those terms are what you need to understand. You can do the same thing with the minimum wage. Again, this is the same idea, what I'm showing you here in this next slide, this slide and the next slide. Same idea, it's just another example. You can do it with the minimum wage. Minimum wage in 2010 was $7.25. Minimum wage in 1964 was $1.15. Obviously, the minimum wage has gone up a lot in nominal terms, right? Just simply the raw number of dollars that you get has gone up. But how much stuff can you buy with a minimum wage, right? That's what you care about. So we have to make a conversion, right? What you do is you'd find out that the CPI in 1964 was 31. CPI today is 220. So you have that ratio 220 divided by 31. Multiply that ratio by the old dollar figure, and you find that the 1964 minimum wage expressed in today's dollars is $8. The actual minimum wage, $7.25, you find that the minimum wage has actually decreased over time, right? If a naive person a person who knows nothing about economics, just a naive person comes up, they're like, oh my God, the minimum wage has gone from $1.15 to $7.25. Naive person might think the minimum wage has increased over time. But if you really take your time and do a conversion, convert the old dollar figure in today's dollars to make an appropriate comparison, you find that the minimum wage has actually decreased over time. This figure here, the figure on the bottom, the brown line, shows you the actual statutory minimum wage, right? It just shows you how many dollars, the minimum wage, how many dollars you have to pay at a minimum when you're hiring workers. And again, you see it's increased from way down here up to the $7.25 figure that we just discussed. But then you can see in the orange line, you can see the adjusted minimum wage figure. And you can see how the minimum wage has, in the 60s and 70s, it was higher. And ever since the mid 80s, it's been kind of in this lower range. It's funny, some people present misleading statistics. I'm sure, I'm sure you're surprised to hear me say that. It's funny because sometimes you'll hear people who kind of advocate for a higher minimum wage to say, oh, the minimum wage is lower now than it was in 1968. People very frequently, I've heard this happen over and over and over again. People pick 1968 as their benchmark for comparisons with the minimum wage, because 1968 was this high watermark. 1968 was when the minimum wage was its highest. So people will say, oh, the minimum wage is lower now than it was in 1968, therefore the minimum wage needs to be increased. Alternatively, you could say, oh, well, the minimum wage has pretty much stayed the same for the last 35 years. It's pretty much the same as it was 35 years ago. Again, I'm not in this fight. I'm not arguing whether it should be higher or whether it should be lower. I'm just saying you can pick specific years and kind of make the whole comparison sound differently, when you're talking to somebody who doesn't see the full figure, who doesn't see the full picture. So an example of dishonesty in public discourse, which I usually don't like, considering I'm an educator, I want full disclosure, full information. Here's another interesting example that needs to be discussed. Now we're talking about interest rates. You go to the bank, interest rates are extremely, extremely low right now, but let's assume we're in the past at some point. Let's say you go to the bank and the interest rate that you see kind of posted on a savings account, let's just say it's 5% interest. The interest rate that you see posted is the nominal interest rate. If you put $100 in a savings account, if the nominal interest rate is 5%, then at the end of the year, you'll have $105. Simple as that. That's the nominal interest rate. Anytime you see an interest rate posted in a bank or somewhere like that, it's always a nominal interest rate. You'll see there are a few places in the world where you will see real interest rates expressed, but it's very uncommon. It's not very common. Anyway, put $100 in the bank. At the end of the year, you have $105. all that means is that you have $5 more. What you care about, though, you don't care about how many dollars you have per se. What you care about is how much stuff you can buy. How much more stuff can you buy now that you've earned this interest? That's what the real interest rate captures. It captures, not how many more dollars you have, but how much more stuff can you buy now that you've had your money in the bank for a year. That's the real interest rate. So, but to do that, the calculation here is simple. It's very simple. It's just subtraction, but you have to remember to do it. You have to be mindful of it. You just start out with the nominal interest rate, the posted interest rate, and just simply subtract from it the rate of inflation. That gives you the real interest rate. So if you earn 5% interest at the bank, but if inflation was 3% over the year, just subtract one from the other, you only can buy 2% more stuff. You can't buy 5% more stuff because inflation has occurred. You can only buy 2% more stuff. People care about real interest rates, not nominal interest rates. It's important to be mindful of this and always kind of think in terms of real interest rates when you're thinking about the economy or when you're thinking even about your own personal finances. So here's a homework problem. This is from the questions that are recommended at the end of the chapter. You have it here on the screen. If you want to review it later, obviously you can pause this video or you can go back in the book and look at it at the end of the chapter. But here we see here you see figures on how much the newspaper cost in 1970 and more recently. And you see figures on kind of the average manufacturing wage back then and more recently. Here you have these various questions. Just pause the video right now and just do this problem. Do the problem, do the simple calculations, but then more importantly, think about what this means. Think about the importance of this problem. Think about why I would be emphasizing this problem. Pause the video, then we'll come back and look at the answers. All right, now we're back. You see the price of a newspaper rose by over 1,200%, and the manufacturing wage rose by 587% over this period. So, first thing, it's important to realize that the CPI gives us an average rate of inflation in the economy. It gives you kind of an overall rate reflective of the overall cost of living for the typical household. But prices of individual goods are changing at different rates, right? Not everything is just moving up smoothly at that average rate. Some prices will be rising more rapidly than others. So it's important to remember that, right? Not everything is just, seeing inflation happen at the same rate. But look at the next one. The next part 3, is what really matters. So you don't really care about the price of the newspaper per se, and you don't really even care about your wage per se, right? Because those are nominal variables, right? Just how many dollars you receive or how many dollars you give up isn't quite what you care about. But what you can really care about is the purchasing power of an hour's worth of labor, right? You work an hour, make $3, make $23. That's not what matters. You work for an hour. What matters is how much stuff can you buy. So if you look at these figures, again, just do the math on your own. The math is all simple arithmetic, so I'm not going to go through that. But you'll see in 1970, you had to work 2.7 minutes to buy a newspaper at the wage that prevailed in 1970. And more recently, you had to work 5.3 minutes to buy a newspaper. You have to work more to buy a newspaper, right? The price of the newspaper has risen more rapidly than the wage. So the real wage has fallen. That's an important term, the real wage, not the nominal wage, not the number of dollars that you receive, but the real wage. How much stuff can you buy? The real wage has actually fallen, at least when expressed in terms of newspapers, right? It could be different expressed in terms of some other good where the price has changed at a different rate. But how much has the real wage changed in terms of newspapers? It's fallen. You have to work, 2.6 more minutes now to be able to buy a newspaper than you did back in the day. The conclusion there at the bottom, newspapers became more expensive in real terms, right? Not just the nominal cost of a newspaper, not how many dollars you have to pay to get a newspaper, but the real cost of a newspaper. How much do you have to work to get a newspaper? That price rose over this period. The next homework problem. Suppose borrower and lender agree on the nominal interest rate to be paid on a loan. I'm borrowing money from you. We agree on the nominal interest rate. We agree that at the end of the year, I'll pay you 7% interest. I borrow $100 from you. At the end of the year, I'm going to pay you back $107. And again, that's what always happens, right? I mean, in very, very rare cases, will somebody agree on a real interest rate, right? People almost always agree on a nominal interest rate. I mean, I guarantee your car loan is a nominal interest rate. Your student loan is a nominal interest rate. Your home mortgage is a nominal interest rate. All these things are nominal interest rates. They're not being adjusted based on inflation. So when we agree on that, if we're smart, we will agree on it, having in mind some expectation of what the inflation rate's going to be. So I might agree to it. I might agree to a 7% interest rate, thinking that inflation is going to be 2%. And so I'm agreeing to, pay you in real terms 5% more. You'll be able to buy 5% more stuff at the end of the year based on this expected rate of inflation of 2%. Right? Again, 7 minus 5, or 7 minus 2 equals 5% real interest. So that's fine. That's how it works all the time. That's so common. But the catch here is inflation turns out to be higher than expected. Inflation turns out to be higher than expected. What does that mean? Just think about it. Pause the video and think about it. If inflation turns out to be higher than expected, then the real interest rate is lower. Right? If inflation turns out to be 5% rather than 2%, then the increase that you observe in your buying power is only 2%. 7 minus 5 now. I'll stop screen share because this is the end of it. This is a key point. I want to emphasize this point. There's not hardly anything in this class that's more important than this point in terms of feeding into some of the stuff that we learn later. If inflation rises unexpectedly, that helps borrowers and it hurts lenders. An unexpected jump in the rate of inflation eats away at the value of the money that the borrower is paying back to the lender. The lender, the increase in the buying power that the lender enjoys diminishes because of an unexpected rise in inflation. That's really important. An unexpected rise in inflation leads to kind of an arbitrary wealth redistribution from lenders to borrowers. And the reverse is, of course, true as well. If inflation is unexpectedly low, then that's an unexpected, an arbitrary wealth redistribution in favor of lenders in that case, right? Unexpectedly high inflation eats away at the value of the dollars that the lender owes, that the borrower owes to the lender. Unexpectedly low inflation preserves the value of those dollars. Those dollars can still buy more stuff if inflation's unexpectedly low. So keep that in mind. When inflation moves around in an unexpected way, it redistributes wealth in our society, and it can create extra risk in our society. And that risk becomes a really important part of understanding how the economy works. We'll come back and we'll talk about that a lot later on. So be sure to remember that point. Anyway, that's it. That is the CPI chapter. Next, we'll come back and talk about the unemployment rate, and then we'll move on to really talking about the meat and potatoes of kind of the macro economy now that we're getting these data-oriented chapters out of the way. Talk to you soon.